Let's see the next topic, that is task communication. Now, based on the degree of interaction, the processes running on an OS are classified as cooperative processes and competing processes. So, now what is cooperative processes? In this cooperating interaction model, one process requires the inputs from other process to complete its execution. So, if there are two processes, the process 1 and process 2 require the input from the process 1 to complete its execution. So this is called as cooperating processes. What is competing processes? The competing processes do not share anything among themselves. They do not share anything, but they share the system resources. So among themselves, they don't share anything, but they share system resources. So what are the system resources here? They usually compete for file, display device, etc. So for these things, these processes will share the common resources like files and display devices. And the cooperating processes exchanges information and communication through following methods. How they do? They follow different methods. One is the cooperation through sharing, and the other one is cooperation through communication. What is cooperation through sharing? The cooperating process exchanges data through some shared resources. This is cooperation through sharing. Means they exchange the data through shared resources. Now the other one is cooperation through communication. Means here the data is not shared between the processes, but they communicate for synchronization. They usually communicate uh, for further processing. Now, the mechanism through which the processes or tasks communicate with each other is called as inter-process communication. You are studying these things in OS also, same concept. The process which communicate with each other is called as inter-process communication. It is essential for process coordination, very much essential for process coordination. The various types of inter-process communication mechanisms adopted by processes are kernel dependent. So different mechanisms are there, but they're all depending on the operating system. Some of the important inter-process communication adopted by various kernels are explained below. So broadly, there are three. What we are going to study here, there are three mechanisms, IPC mechanisms. Now let's start with the first mechanism, that is shared memory. Now, processors share some area of memory to communicate among them. Information to be communicated by the process is written to the shared memory area, and other processes which require this information can read the same from the shared memory area. So let us understand with the diagram. So the processes, uh, whatever it wants to put, share some information to be communicated by the process. What it does, it will put it to the shared memory area. So here you are seeing process 1, whatever it wants to share, it will put into the shared memory area. And that could be shared by process 2. It can be taken by process 2. Now, the implementation of shared memory concept is once again kernel dependent. Again, in this shared mechanism, broadly, the IPC mechanisms are three. First one is the shared mechanism. Among all the three IPC mechanisms, the first one is the shared mechanism. Again, under that, we are going to see there are few mechanisms in the shared memory concept. There are few more mechanisms. So the first one is a pipe. So now let's see the pipes. Pipe is this section of shared memory used by processes for communicating. In the Unix, we make use of this concept of pipes. So pipes follow the client server architecture, means a process which creates a pipe is, you literally also you can imagine, if you relate to the real time entity, the pipe, you know that at one end you're entering the putting the data, the other end you can take it. So it follows a client server architecture. A process which creates a pipe is known as pipe server, and a process which connects to a pipe is known as pipe client. The one which wants to send some information or has some information, it will create a pipe, and that is called as pipe server. And the other process which wants to connect to that pipe is called as pipe client. So this is the concept. Now, process 1 writes to the pipe and process 2 reads from the pipe. So this is actually a type of shared memory. Shared memory is a concept. So how you are going to implement shared memory? One is through pipes. Now, the implementation of pipes is also once again operating system dependent. Microsoft Windows desktop operating system support two types of pipes. Again, we have a subdivision here. So first one was IPC mechanisms, shared memory. And in that shared memory, we discussed about pipes. Again, in that pipes, we are talking about different types of pipes. There are two types. One is anonymous pipes and the other one is named pipes. What is anonymous pipes? Anonymous pipes, by name itself, they tell it is unnamed. And they are unidirectional pipes used for data transfer between two processes. These pipes they don't have names and they're actually unidirectional. The data can be transmitted only in one direction between the two processes. Now, in case of named pipes, named pipe is named unidirectional or bidirectional. In case of this category, the pipes are named and they can be unidirectional or bidirectional pipe for data exchange between the processes. And so with this, the data can be exchanged on both the sides. Now let us go to the next category, that is memory mapped objects. So again, let me just brief it. The first one was shared memory, and now we are going for in the shared memory we had, yes, let me just brief it. In the shared memory we had yes, in the shared memory we discussed about the first concept, that is pipes. Now we are going to see the second concept, that is memory mapped objects. So this is the second category. So we discussed pipe, that is one category of shared memory, and now we are going to talk about memory mapped objects. Now, memory mapped object is a shared memory technique adopted by certain real-time operating system. They are usually used by real-time operating system for allocating a shared block of memory, which can be accessed by multiple processes simultaneously. So this is used in RTOS, and here the shared block can be accessed at the same time or concurrently. It can be accessed by multiple processes. So this is the second category, and we don't have a subdivision. Now we are going for the next category, that is message passing. So now in case of message passing, it is a synchronous information exchange mechanism used for, again, it is also a type of, among three mechanisms, the first mechanism is shared memory, it is over. Now we are talking about the second mechanism, that is message passing. Now, the major difference between the shared memory, and that is that they're comparing, the major difference between the shared memory and the message passing technique is that through shared memory, means the previous technique, whatever we studied, pipes and memory mapped objects, whatever we have studied previously, there lots of data can be shared. But in case of message passing, that is the right now this technique, in case of message passing, only limited amount of information can be passed. Henceforth, this message passing is relatively faster. So there is a comparison. Whatever we studied in the shared memory, like pipes and shared memory objects, there lots of data can be shared, but it is slow. In case of message passing, only limited information of data can be passed through message passing. Henceforth, it is very fast. So again, we will see under message passing. Under message passing, now I'm talking about the different categories of message passing. We have three categories. One is message queue, other one mailbox and signal. So let's discuss the message queue. So the message queue is nothing but the process which wants to talk to another processes, posts the message to the first in first out queue, which stores the message, and this queue is called as message queue. and it stores the messages temporarily in a system-defined memory object to pass it to the desired process. Now, if you see here, you're seeing here, this is a message queue. The process which wants to send some information, what it does, it will send a message through first in, first out to message queue. And the process which wants to receive, in the same order, it will receive from the message queue. Now, to implement this mechanism, messages are sent and received through send and receive functions, send and receive methods. What does the send method has? Now, this process one want to send some message to this queue. What does it has? It has a name of the process to which the message has to be sent and the message. So to which process it has to send, that name of that process and the actual message will be sent through message queue through send method. So it will be there in the message queue. Now, suppose the process 1 has sent to want to send to process 2. So what it will tell? What is the name of the process? It is process 2, and whatever the message it is there, it will post through send method. Now process 2 has to receive it. So it will use a receive method. Now, from which it has to receive the message, it is from process 1. So the receive method will have the name of the process from which the message is to be received and the message, the actual message. So it gets substituted. So from there, message queue, the data will be received by process 2. These messages are always exchanged through message queue. So these messages are exchanged through message queue.